Our group created a DIY cardboard elevator project using a simple pulley mechanism. We wanted to build something handmade that still demonstrates real physics concepts. The main question we focused on was, how can we lift a load up and down using a simple machine without electricity? This question helped us understand how elevators work at a basic level. The purpose of this project is to show how a pulley reduces the input force needed to lift an object and how Newton's second law, F equals ma, applies when the elevator moves. We also wanted to explore the connection between force, mass, acceleration, and gravity. As a group, we came up with our design idea creatively, but we also supported our work by doing research to understand pulleys and simple machines more deeply.
The first concept is Newton's second law, F equals ma. This means that the acceleration of the elevator depends on how much force we pull with and the mass of the platform. If the mass increases, more force is needed to lift it. Next is weight, which is calculated by W equals mg. Gravity always pulls the elevator downward, so any lifting force must overcome that weight. All models use a single fixed pulley, which has a mechanical advantage of 1. This type of pulley doesn't multiply force, but it changes the direction of the force, which make it easier to lift something by pulling downward or rotating a handles. We chose this project because, as a group, we enjoy building creative models. It's simple, low cost, and a great way to understand physics using recycled materials.
So now I will talk about our design plan and materials. Our design is a rectangular cardboard frame with enough space inside for the elevator platform to move smoothly. At the top, we added a wooden stick to act as the pulley axle and the string loops over it. We also attach a handle to the axle so that when it turns, it wind or unwind the string. The material that we use: 1 cardboard, 2 wooden stick, 3 string, 4 glues and tape, 5 a small box for the elevator, and 6 marker for decoration. For the method, first we plan the size of the elevator, and then we sketch the layout. Then we cut the cardboard piece for the wall and platform. After that, we glue the frame together and place the pulley stick at the top. My main responsibility were cutting the board and gluing important parts to make the structure strong.
I work mainly on building the pulley system and helping with the cutting. After the frame was built, we tie one end of the string to the elevator platform and loop it over the pulley. I built the handle mechanism, which lets us rotate the pulley so the elevator can move up and down. Like most engineering projects, we faced some problems. The first mistake was that our pulley wasn't strong enough. The axle shook when we turned it, so the elevator didn't move smoothly. We fixed this by adding more cardboard support to keep it steady. Another issue was that the elevator sometimes didn't go down. This happened because the string got stuck or the platform wasn't balanced. We solved this by adjusting the tension, reducing frictions, and making sure the elevator stayed straight. These challenges actually help us understanding physics better, especially stability and force.
For proof of work, we test the elevator many times. When we turn the handle clockwise, the string winds up and lifts the platform. When we turn it the opposite way, the string unwinds and the platform moves down. This shows how pulleys can transfer force and demonstrate acceleration, gravity, and motion. Here are our group roles. In lead the planning and guide the team. Andy cut the board and help glue the structure. Paul Jai help write the script and did decoration. BAM. Build the pulley and handle system. Me. Help the gluing and assembling the main body of the elevator. In conclusion, this project helped us understand pulleys, Newton's laws, and how force and mass affect motion. By combining creativity, research, and teamwork, we built a working elevator using only simple materials and no electricity. Thank you for listening.